Hi, welcome to another lesson from Deptford Tutors. Today what we're going to look at is how to do algebraic proof. This is for GCSE grade 9 to 1. Now, I've picked 5 questions, for us to go through. You can see them on the screen. A lot of people have been asking me how to do algebraic proof, so I thought I'd make this video. If you feel that you know what to do already and you just want to attempt the questions, you can look in the description, click on the actual time of the question and go straight to it. If you're like most people who haven't got a clue about how to do this, what we're going to do, we're going to briefly touch on these 3 areas: odd and even numbers, consecutive numbers, expanding bracket shortcuts. This is more of a primer to help you access these types of questions here, and they will come up in your exam. There's no getting away from it. Okay, you can actually download the lesson slides on this for this lesson, and you can follow along with it as well. The link is in the description. It will take you directly to that paperwork. Also, I've attached the answers as well, so it's not just lesson slides. If some people just want the answers, which is fine. Also, make sure you put down a like, you subscribe, and you click the bell so that you know when I make another video. Also, try and use the comment section to help each other as well, because I like that kind of, classroom setting. Because also when other people come to view the videos as well, they may have the same type of questions and it can easily be answered in the comment section. So let's get straight in. Right, so we will briefly cover the following topics: odd and even numbers, consecutive numbers, and expanding bracket shortcuts. Okay? You need to understand this part or these parts because it will give you context on how you answer these types of questions. Let's get straight into it. Right, okay. Odd and even numbers and how they relate to algebraic proof. Your first positive odd number is 1. Your first positive even number is 2. We'll just go up to 3, 4, 5, 6. Okay, obviously it continues on, but that's all we're going to do for now. Listen very, very carefully. When doing algebraic proof, try your best to write the first odd number as 2n minus 1. This is let's write that one a bit clearer. This is a general rule. 2n minus 1 is the first positive odd number. Okay, this is when n is equal to 1. Okay, I'm saying the first term in this sequence here that I've made, 1, 2, 3, 4, 5, 6, the first term written algebraically is 2n minus 1 when n is 1. Okay, how can I actually let's look at this in more detail. What does 2n minus 1 actually mean? It means 2 times some value of n, subtraction of 1, will give me an answer. But I've set up here that n is equal to 1. So if I replace n with 1, I should get an answer, right? Let's do this. So 2, open brackets, because you should know how to do bid maths by now. I'm going to replace that n with the number 1 because that's what it says is equal to. Take away 1. 2 times 1 is 2. Take away 1 equals 1. Okay, so now 1 tallies with that one here, look. That's interesting. So, just so you know, here, 2n minus 1 is your first odd positive whole number. So what would 2 be then? because we know that's even. Yeah, I'm going to write it as 2n. That's it. Why have I written it as 2n? Because we've just said that n is equal to 1. And I'm looking for number 2, aren't I? So I'm going to do 2, open brackets, replace this n with 1. Because we know 2n means 2 times n. So 2 times 1 equals 2. Nice and easy. What about 3? Well, if I'm at number 2 and I just need to get to number 3, I've got to add 1 on, isn't it? So I'm going to say, therefore, 3 can be written as 2n plus 1, because that's 2 add 1, which is 3. But does it make sense when I replace n with 1? Let's try. 2, open brackets, 1 plus 1. 2 times 1 is 2, add 1 is 3. Oh, it works. So I think we can kind of get an idea of what's happening now. Number 4 is going to be 2n plus 2. Okay, this is an even number. Notice here your remainder is even. If I said that n is equal to 1, will I get 4? 2 open brackets plus 2. 2 times 2 is 2 times 1 is 2. Add 2 is 4. Perfect. Let's do 5. We're getting a pattern now. That's going to be 2n plus 3, because our previous number, 4, was 2n plus 2. We're just adding another digit on. Open brackets, replace that with 1. We're getting the 1, okay, from here, because we've made that assumption that n is equal to 1. Okay? 2 times 1 is 2, plus 3 is 5. And finally, number 6. 2n plus 4. 2 open brackets 1 plus 4. 2 times 1 is 2, plus 4 is 6. So, using algebra, we've now got some values. We've got 2n minus 1 is 1. 2n is 2. 2n plus 1 is 3. Okay. 2n plus 2 is 4. Oh, Jesus. 2n plus 3 is 5. 2n plus 4 is 6. Okay. So what we've now done, obviously this goes on to infinity, but we're just using these 6 values here. And you can clearly see that we've used algebra, okay, to write numbers 1, 2, 3, 4, 5, 6 in some kind of a way that can be used to answer the questions that we've got coming later. Okay? Yeah? So how does this relate to consecutive numbers? Well, if any of you understand what consecutive numbers are, 1, 2, 3, 4, 5, 100, 101, 102. Those are consecutive numbers. They come after each other. Okay? So I'm going to do the same thing here, just underneath. Don't worry, guys. Remember, these slides are online, so you can get access to them. So let's write consecutive numbers from 1 to 6. 1, 2, 3, 4, 5, 6. Okay? These are consecutive numbers. Okay? I'm going to write them algebraically, as we've just stated in here. Our first number, which is 1, was 2n minus 1. Our second number, which is 2, was 2n. Our third number, which is written here, is 2n plus 1. Our fourth number, which is here, is 2n plus 2. Our fifth number is 2n plus 3. Our sixth number is 2n plus 4. What we have just done is written out numbers 1 to 6 algebraically and consecutively. So if I'm at 2, okay, I'm at 2n here, the next consecutive number would be written as 2n plus 1. If I'm at 2n plus 3, the next consecutive number is 2n plus 4. Okay? Now let's take this a bit further now. Okay? I'm going to highlight the odd numbers. Odd number, odd number, odd number. Okay? What I'm going to do now is write 1, 3, and 5 here. Okay? Now, these are consecutive odd numbers. Previously, we looked at 1, 2, 3, 4, 5, 6. Those are just consecutive whole number integers, okay? Now we're looking at consecutive odd numbers. And I'm going to write them here. 2n minus 1. 2n plus 1. Let's put our commas in. 2n plus 3. What we've just done is written out 3 consecutive odd numbers using algebra. Now, obviously, let's highlight our even numbers. Okay, because we're going to write those ones out as well. If you can get this, these questions are not a problem at all. They're going to be so easy for you. Okay, 2, 4, and 6. We know that 2 can be written as 2n. We know that 4 can be written as 2n plus 2. We know that 6 can be written as 2n plus 4. Okay? What we've got here are consecutive even numbers. And we've done the exact same here. Right? If you are unsure about what I've just talked about here and what I've taught, I would advise you to go over the slides again. Okay? Try and practice some as well. You can even put some into the chat. Yeah? But it's very important that you understand this concept before we even attempt to do an algebraic worded proof question. Okay? If that was helpful so far, please leave a like. Okay, so we're looking at expanding bracket shortcuts now. It's useful to be able to do this because when you are attempting algebraic proof questions, even when you're completing the square, sometimes it's good just to be able to do things a bit quicker. What do I mean? Let's say you have a question like this here. 2n plus 1 squared. You should know that this squared term means that it's actually 2n plus 1 multiplied by 2n plus 1. Okay? Now, we're going to expand it the long way just to show you what I'm talking about. Okay? And then I'm going to show the shortcut that we're going to be using for the remainder of this lesson. Right, so we've got 2n times 2n, which is 4n squared. 2n times 1, which is going to be 2n. Onto this term now. 1 times 2n, which is plus 2n. 1 times 1, which is 1. So this is going to give you 4n squared. You simplify these two terms. Let's make that a bit of a neater line. Okay, maybe not. Okay, and then you've got 4n plus 1. Okay? Now, doing it a different way, more efficient, over this side. We've got two terms in here. We've got 2n and then we've got a positive 1. Outside the brackets is a squared term. I'm going to square 2n. That's going to give me 4n squared. I'm going to square positive 1. That's going to give me plus 1. Then what I'm going to do 2n times 1, which is 2n. Then take that answer of 2n and times it by 2. And that's going to give me 4n Okay, rearrange it in the form of a quadratic expression. We have the same answer. Okay, I'm going to attempt to do another question just to help you out. All right, let's do it here. Let's go. Let's try something like, I don't know, 3n minus 2. Okay, let's do it the long way first. Actually, no, we're not going to do it the long way first. You should know how to do that. We're going to do the shortcut version now. 3n, we're going to square the first term. That's going to give me 9n squared. I draw an arrow so you know where it's coming from. We're going to now square minus 2. Minus 2 times minus 2, let me write it out because some of you are going to ask me, and I'm like, you shouldn't even be asking me at this point. Minus 2 times minus 2 is positive 4. Okay? That's going to give me plus 4. Okay? Now what I'm going to do, I'm going to do 3n times minus 2, which is going to give me minus 6n. I'm going to take that answer of minus 6n and I'm going to times that by 2. And that's going to give me minus 12n. Okay, I'm just going to write that part out here. We did 3n times minus 2, which is from at the bracket as well, and times by 2, which is a square term here. And that gave me minus 12n. That's where that comes from. Okay, so let's try and tidy this up now. 9n squared minus 12n plus 4. Okay, let's do another one. Let's do, I don't know, 5n plus, I don't know, 3. We'll do that. 5n plus 3 squared. Let's do the first term. We're going to do, I'll write it out here, 5n squared. Actually, let me rewrite that because that looks like something totally different. We're going to do 5n and square that. That's going to give us 25n squared. Okay, let's do the 3. We've got 3 in brackets and square it. That's going to give me positive 9. Then we're going to do 5n times 3 times 2. Let's change the color. 5n times 3 times 2. Okay, and that's going to give me 5 times 3, 5n times 3, sorry, which is 15n. Okay, then 15n times 2 is 30n. So our final answer is 25n squared plus 30n plus 9. We can prove that by doing it the longhand way. Let's do that then. Let me just underline that so you know that's your final answer. And it's always good just to check. So let's do that now. Okay. I won't bother with putting different colours in. I'm just going to draw the arrows so you can see what I'm doing. Okay. 5n times 5n is 25n squared. 5n times plus 3 is going to be 15n. 3 times 5n is plus 15n. 3 times 3 is 9. Simplify these two here. You're going to get 30n. So that's 25n squared plus 30n plus 9. You see, this answer is identical to this one here. Okay, so going forward, we're going to be using the shorthand method to expand out brackets. Okay, so let's get down to the nitty-gritty now. We are on question number 1 of the 5 questions. It says here, prove that brackets n plus 1 squared take away from n minus 1 squared plus 1 is always odd for all positive integer values of n. Okay? Now, what is that question actually saying? First of all, it's saying we're looking for an odd number in our answer. Yeah? So that means we're going to have a remainder of 1, 3, 5. Yes? Okay? It's going to be a positive integer. So we're not looking for a negative answer. Okay? Our answer can't be negative because it's saying here to prove this here. Okay? All they're asking you to do, actually it's not just that, it's all this. All they're asking you to do is expand out those brackets, but you need to know how to do it correctly. That's why we had to go through it previously. So let's do this. So I'm going to write it out like this. N plus 1 brackets squared minus, okay, I'm going to do a parentheses here, then the bracket. The reason being is because, oops, try that again. The reason being is because this negative term here is going to change the signs of all the terms inside this bracket. So it's just good, neat mathematics to do it properly. Yeah. Okay. So this is our expression here. So just as we did in our previous example, I'm going to expand out these brackets using the quicker method. That's going to be n squared. I'm doing this one first. That's going to be plus 1. Then 2 times 2. N times 1 is n. Times 2 is going to be plus 2n. Minus. And inside this bracket here, okay, we've got n squared. That's going to be n squared. Then minus 1 squared is going to be plus 1. Okay, we should know this now. And then n times minus 1 is minus n. Minus n times 2 is minus 2n. Close that. Then put plus 1 on the end. Okay? Now, if you notice, this one here has a negative term. So that means all the signs inside of this bracket are going to change because of this negative term. So I'm going to have n squared plus 1. I'm just writing this one above, underneath here. Then here, minus 1. This means a minus 1, basically. Minus 1 times n is going to become n squared. So it's minus n squared. Minus 1 times 1 is going to become minus 1. And this one, minus times a minus, is going to become plus 2n. So this is expanded now. And then I write this plus 1 at the end. Okay? Now, these two can cancel. These two can cancel. And then what we're left with is plus 2n, and a plus 1. So 2n plus 2n plus 1, that's going to give me 4n plus 1. So, first of all, is this answer positive? Yes, because it doesn't have a negative sign in front of the 4. Yeah? Is this answer an odd number? Well, if I know that 4n, okay, is positive and even, but then we've got a plus 1 on the end, that means there's a remainder of 1. So that tells me that you can't factorize 2 out of this. You can't divide it through by 2. What do I mean? If it was 4n plus 2, I could factor out 2 out of both sides of this expression here. Yeah, or both terms, sorry. So, how many 2's are in 4? There are 2. And how many 2's are in 2? There's 1. So I would know that therefore, when I multiply these together, I get an even number. This is not the case because we've got a 1 here, okay? And 2 can't go into 1. It can only go into 4. Therefore, this is an odd number, okay? And if we go back to our first odd number, it was written as 2n minus 1. 3 would have been written as 2n plus 1. You see what's happening? 5 was written as 2n plus 3. Notice our remainders here are odd numbers, just like what we've got here. So we can conclude and confirm that this is our final answer and we've got it correct. Okay, here's the next question. Prove that 3n plus 1 squared minus 3n minus 1 squared is a multiple of 4 for all positive integer values. What is a multiple of 4? Okay, just for those who don't know, 4, 8, 12, 16, 20, and so on. Okay? Okay. Now, what we're going to do, we're looking for an answer that's going to be a multiple of 4. 4, 8, 12, 16, 20. Or it has to, our final answer has to contain some element of that. We either find that by factorizing, etc. Okay, so let's do it now. 3n plus 1 squared minus, okay, I've got my parentheses again because we've got a negative term here. 3n, and I would encourage you guys to do it as well because it's very easy to make that error. Okay, let's expand it. We should know what we're doing now. First term, 3n squared. 3n and we square it, it's going to give us 9n squared. 1 squared is just going to be 1. 3n times 1 is 3n. 3n times 2 is going to be plus 6n. Minus, which has come from here, brackets, 3n, and we're going to square it, 9n squared, minus 1, square it, it's going to give us plus 1. 3n times minus 1 is minus 3n. Minus 3n times 2 is minus 6n. Okay? The signs are going to change in this bracket now. So I'm just writing out this one here. Minus, that's going to become minus 9n squared. That's going to become minus 1. This is going to become plus 6n. Now we can obviously cancel off some of them. 9n squared can cancel. Positive 1 and negative 1 can cancel. And what we're left with is 6n plus 6n, which equals, oops, doesn't equal that, equals 12n. Now you might be wondering, 12n? Ah, this means 12 times n. Isn't 12 a multiple of 4? Yes, it is. Okay. Is it positive? Yes. So our final answer, therefore, is 12n. Give yourself a pat on the back if you got that right. Okay. Prove algebraically that the sum of the squares of any two consecutive numbers always leaves a remainder of 1 when divided by 4. So first thing we're going to do is prove it algebraically. Okay. Secondly, they're looking for the sum of squares of any two consecutive numbers. That could be 2 plus 3, 4 plus 5, 100 plus 101. Okay? But they want it in the form that's algebraic. And they're looking for the squares as well. So they want this. Okay? At some point we're going to have to square these. Yeah? But I'm going to use this example as it's easier. Hopefully some of you can remember how we wrote number 2 algebraically. We did it as 2n. The next one would be 2n plus 1 because that would be a consecutive number. And we're going to add them together. But they're asking us to sum up, they want the sum of squares, not these. So we want us to square them. So let's do that now. 2n, if we square it, we're going to get 4n squared. Let's do this one. Remember, there's two terms in here, so this is going to give us a quadratic expression. 2n squared is 4n squared. 1 squared is positive 1. 2 times 1 is 2n, times 2 is 4n. Let's simplify that now. We can add these two together. It's going to give me 8n squared plus 4n plus 1. Now they're saying here, prove algebraically that the sum of squares of any two consecutive numbers, which we've got here, always leaves a remainder of 1 when divided by 4. Okay. If I am going to decide to do this now, I'm going to factorize it and take 4 out and see what happens. You should know how to factorize by now. I do have a video based on this. So I'm going to factorize this out by 4. So I'm going to get some brackets, yeah? Put 4 outside. How many 4s are in 8n squared? There's 2n squares of them. How many 4s are in 4n? There's going to just be 1. So we're going to write it as plus 1. Okay? Plus n, sorry, my bad. Okay? And here we've got outside the bracket, because we can't do anything with the 1, it's just going to be plus 1. We're back to it again, where we've got the plus 1 on its own. This is your final answer here. Okay? Because remember, when you multiply 4 by everything inside the bracket, you're going to get a positive number. Okay? But you're going to be left with a remainder of 1 at the end. Right? So this is what they mean. It shows you here. We've just proven algebraically that the sum of the squares of any two consecutive numbers always, so it's true in all cases, leaves a remainder of 1 when divided by 4. Okay? Okay, if you found this video helpful so far, please make sure you click the like button. Also click that bell, the notification bell in the top right hand corner, of the screen, so you know what videos I'm going to be releasing, and also subscribe to my page. Let's do question number 4. Prove algebraically that the difference between the squares of any two consecutive odd numbers is always a multiple of 8. We covered this in the primer earlier on in the lesson. So, consecutive odd numbers, that could be 1 and 3, or 9 and 11. Okay, we're just going to pick 1 and 3, and they want the difference of squares, yeah? The difference between them. So we're going to be subtracting, not adding. Okay? So if you recall how to write 1 in using doing it algebraically, that's what we got here. And to do 3 is 2n plus 1. But what they want to do is work out the difference of the squares. So we're going to square this, okay, and square this as well. Okay? Let's do that. 2n squared is going to be 4n squared. Minus 1 squared is positive 1. 2 times minus 1 is minus 2. Times 2 is minus 4n. Okay. We're doing this one now. 2n squared is going to be 4n squared. 1 squared is positive 1. 2n times 1 is 2n, times 2 is going to be plus 4n. Now you should already know now that the signs inside of the bracket are going to change because we have a negative sign outside. Let's do that now. That's going to become minus 4n squared minus 1 minus 4n. And let's bring down these ones here. 4n squared plus 1 minus 4n. Let's see what we can cancel. We can cancel the 4n squareds because they'll cancel out to give you 0. We can cancel out the 1s because they'll give you 0 as well. And what you're left with is minus 4 and minus 4. Now minus 4 minus 4n and minus 4. Minus 4n minus 4n will give you minus 8n. Okay? Now, it doesn't tell you that your answer has to be positive for all, represent for all positive integers. It just says it needs to always be a multiple of 8, or you need to show that. Okay? What we've got here, we've got 8 times minus n, because that's what it means. That's what this means here. Okay? Let me highlight that for you. Okay? Now, we went through what multiples are. Multiples of 8, 16, 24, etc., etc. Yeah? Now, clearly, 8 is a multiple of 8. Therefore, this is our final answer here, minus 8n. Okay? Because what we've done, we've proven algebraically that the difference between the squares of two consecutive odd numbers, these are our consecutive odd numbers. This is 1, this is 3. This is how we write number 1, this is how we write number 3. And we've got the difference here, which we were subtracting to find that. Yeah, is always a multiple of 8. And what we've got here, minus 8n, clearly 8 is a multiple of 8. So that's our final answer there. Question number 5. Prove algebraically that the sum of the squares of any 3 consecutive even numbers is always a multiple of 4. Consecutive even numbers, 3 of them as well. So that's 2, 4, and 6 because they're even numbers and they're consecutive even numbers. Okay, why are they consecutive? Because 3 is odd, so therefore it's not even. How can I write 2 algebraically? That's 2n. How can I write 4? 2n plus 2. How can I write 6? 2n plus 4. We covered this in the primer earlier on in the lesson. So if you are unsure, you can always go back and revisit it as well. Remember, the slides are online. You can get hold of them by clicking the link in the description. So they're saying here that the sum, so we're going to be adding them, of the squares, we're going to also be squaring them. So let's get rid of these commas. Okay, let's put some brackets here and square that. Brackets here, square that. Brackets here, square that. And we're adding these 3 numbers together. Okay, we should know that this is going to give us 4n squared. Okay, plus, yeah, then we're going to have 2n squared, which is 2n, and you square it is 4n squared again. 2 squared is going to be positive 4, and then 2 times 2n is 4n, times 2 is going to be 8n. Okay, so that relates to this one here. Right, this one relates to this one here. Now onto the third bracket. 2n squared is going to be 4n squared. Okay, 4 squared is obviously going to be 16. 2n times 4 is 8. 8n times 2 is going to be plus 16n. Okay, and I draw an arrow, and this relates to all of these terms here. Now what we're going to do is simplify this. Okay, let's start with the 4n squareds. Okay, that's going to give me 12n squared. Okay, let's choose a different color. Let's deal with our n's. We've got n here and n here. That's going to be plus 24n. And let's get this one here. Then we've got our whole numbers here, our constant terms. It's going to be plus 20. Now, we've got an expression that says 12n squared plus 24n plus 20. And they're saying, prove algebraically that the sum of the squares of any three consecutive even numbers is always a multiple of 4. Always a multiple of 4. So basically, does 4 go into it? Can we factorize 4? Yeah, let's try. Let's put 4 outside the bracket. Okay, how many 4s are in 12n squared? There's 3n of the squares of them. How many 4s are in 24? There are 6. That becomes 6n. How many 4s are in 20? There are 5. You notice what's just happened? Yeah? It's definitely going to be a multiple of 4 because 4 has to be a factor of it. Yeah? So 4 is a factor of all of this here. Okay? So what we've just done now, we've proven algebraically, okay, that this is our final answer here. Yeah? That the sum of squares of 3 consecutive even numbers, which is 2, 4, and 6, are always a multiple of 4. Our multiple of 4 is here because this means 4 times everything inside that bracket. And it gave us this term. Therefore, we are correct. Right, so we've reached the end of the lesson now. And I hope that this proof lesson has been helpful. A lot of students find proof difficult because, in my opinion, as a maths teacher, it's not taught properly. So I've tried to do some groundwork because the primer that we did at the beginning of the lesson, those are the types of questions and issues that students find hardest, and that stops them from being able to access the answers and do the work properly. So I hope it was useful for you. Make sure you subscribe to my page, and also click a like if you haven't done that already, and also click on the notification bell in the right hand side of the screen. I think it's somewhere up there, so you know when I make another video. And if you can, and I don't have many videos at the moment, but I do have some useful ones, so have a look at some of these videos and see if they're going to be of help to you. They're also up on the blog as well, which is here. So for instance, now if you want to look at recurring decimals, there's some information on those. Also as well, probability, QTS, if that's what you're looking for as well. Also, if you are looking for an online maths tutor, please get in contact with me on my website. The link is in the description. You can contact me through this here, or you can contact me through YouTube. I do offer paid sessions. They are online and they are group sessions, paid sessions as well. If that's what you're interested in, you can also contact me on the telephone number that's on the screen here as well. That is my number. I am a real person. When you go onto my website, there are some photos of what we do, and also I am actually on there as well, for those who care. Yes, I hope it was helpful. Thank you very much. Bye.